Okay, physics, final review. Here we go. So let's look at what we have. So number one asks for us to work with a resistor. And our resistor has a battery. It has a branch, and then it has 1, 2, 3, 4 resistors labeled R1, R2, R3, and R4. Okay, great. The problem says find the power, so we're trying to find the power, and this is number one, in the resistor 4, so power of R4 is what we're looking at. If the EMF, which is the voltage, is 40 volts, and the resistance are 10 for R1, 15 for R2, R3 is 25 ohms, all of these are ohms, and 5 respectively. And we're assuming no internal resistance, so that is our circuit. So first thing I need to find, if I'm going to find the power, I'm looking for the power of this one. I need to know what is the total resistance, R net. Okay, so current leaves out this side, it wraps around. I see I have a current split here, and I have the current coming back together, which means these are both on the same parallel branch. So they're in series, and in series we add them together. So this is a 30 ohms branch, this is a 15, and that's 10. So I want to collapse this parallel branch. To collapse the parallel branch, 1 over R is equal to 1 over 30 plus 1 over 15. Okay. We can just play the fraction game with that. 1 over 30 plus 2 over 30, which equals 3 over 30. 1 over R equals 1 over 10. R equals 10. So this is collectively 10, which means R net is going to be 10, 20. Now the reason why I wanted R net is I want to know how much current gets in the R4. So I need to find I net now. And the formula I'm using is V equals IR. So I net is simply going to be 40. So 40 is my voltage, is equal to I net divided by the resistance, which is 20. I is equal to 2. So I have 2 amps coming here. Now my next issue is these amps are going to split. And when they split, more of them are going to go the R2 branch because the traffic or resistance is less. Less will go that way. I need to know that split. The rule I taught you is take the largest resistance, in this case it's 30, and divide by itself times I plus the largest divided by the other branch. In this case it's 15 times I is equal to I net, which in this case it's 2 amps coming in here. So 1I plus 2I equals 2 amps. 3I equals 2 amps. I equals 0.67. You now take that and plug them into both. So we have 0.67 amps goes to the right, and 2 times that, or 1.3334 amps goes down. So R4 then we'll see 0.67 amps along this entire pathway. Power equals I squared times R. Okay, for those of you who don't remember where we got that, power is equal to I times V. If V is replaced with this, it's I squared R. I is 0.67, so that would be squared, and the resistance I care about is 5. So 0.67 squared times 5. The power is 2.24, and power is in watts. There's your answer to your first problem for your final review. Okay, a little involved, but a lot of good solid things. Good luck.